Hello students. In the previous videos we have taken some examples on convolution integral, two different cases there, and here we are taking the next kind of problem. Here the problem is given like this: convolute the two continuous time signals x1 of t is equal to u of t plus 2 minus u of t minus 1, and x2 of t is equal to u of minus t plus 2. Now I have plotted x1 of t and x2 of t. I will just go through the steps in brief. So here the first signal u of t plus 2 is drawn, which is having a amplitude 1, and minus u of t minus 1 is plotted here. Now we have to add these two, that is t plus 2 and this. You have to perform addition to get x1 of t. So from minus 2 to plus 1, we don't have any signal here at minus u of t minus 1. Now if you get added to this signal from minus 2 to minus 1, you will have the amplitude 1, and from 1 onwards the amplitude is 1, and here it is minus 1, plus 1 minus 1 will become 0. So after 1 the signal will become 0. So this is the plot of x1 of t. Now coming to x2 of t, it is u of minus t plus 2. So first I have plotted u of t plus 2, then time reversal operation is performed on this. So you will get u of minus t plus 2. So that is the x2 of t signal. So this completes the plot of x1 of t and x2 of t. You can observe this. This one is a rectangular signal and this one is a unit step function. Now for these two signals we have to perform convolution. So from the definition of convolution, integral, so y of t is equal to, I will go with x1 of t convolved with x2 of t. That means I want to keep this as static and this as a time shifting one. Okay, you can go with x2 of t convolved with x1 of t. It's your choice. Okay, and based on this, my expression will be tau is equal to minus infinity to plus infinity x1 of tau x2 of t minus tau d tau. So call this as equation 1. Now let's plot x1 of tau and x2 of t minus tau. So using x1 of t, I am plotting x1 of tau. So time index will be tau here, and signal varies from minus 2 to plus 1. Okay. Now x2 of t minus tau, we have to plot by considering t is equal to 0. Then the plot will look like this. So you can observe this. We have x2 of t signal from minus infinity to plus 2, the signal exists, and after 2 it is 0. But when you take x2 of t minus tau, so we have to take x2 of minus tau with t is equal to 0. So I will directly plot this. So here, so this is the starting index, which is our reference to take the limits. Now this will be defined as tau is equal to t minus 2, because here tau is equal to tau is equal to t here. This one becomes tau is equal to t minus 1, and here it is tau is equal to t minus 2. So that is our reference point. So now let's perform convolution. So I'll considering case 1. So first I will I have to take I have to see the starting index of this signal, that is x1 of tau is from -2 to +1. Okay. So now let's take the shifting signal. So you can observe this, it is varying from t-2 to infinity, that is with respect to varying with respect to time tau. Now if I keep this t-2 here, that is below the starting point of x1 of tau. So if I keep it here, then the signal will be overlapped. So let's define them. x2 of t minus tau. The signal will be having same amplitude 1 and 1 both the cases. Okay, so here I have not mentioned. So the one here. So both the cases the amplitude is same. Now if you see the overlapping region, so the overlapping region is this. That means the signal is overlapping from -2 to +1. So this is the overlapping region now. Now how to define this case? For t-2 less than -2. So this is the first case. So then what happens to this? If you simplify this, that becomes t less than 0. Okay. Either you can write it less than 2 or less than or equal to 2. That doesn't change any, that doesn't make any difference. Yes, of course it makes difference. So let's consider like this, t less than 0. So this is the condition for t less than 0, our y of t. What will be the y of t value for this particular case? Let's see that. Now the overlapping region is from -2 to +1, x1 of tau, x2 of t minus tau, d tau. Now x1 of tau is also 1 and x2 of tau is also 1 in this particular duration. So this will be the one which we are going to integrate. Now integration of this is tau, because integration of 1 is tau with respect to tau. If you apply the limits and simplify, you will get the answer as 3. So now for t less than 0, our y of t is equal to what? 3 here. So this is the first case. Now let's take the second case. So this is my x1 of tau in varying from -2 to +1 with amplitude 1 here. Now in this case I will place this t minus 2. This t minus 2 was here less than -2. Now I will keep this between -2 and -1 in the next case. So I will place it here. Okay. So this is my t minus 2 and this is my x2 of t minus tau with amplitude 1. Now if you observe, the overlapping region is from, this is the overlapping region, and if you look at this part is the overlapping region, that is from t minus 2 to 1. So this is the new overlapping region we got. Now how do you define this case? For t minus 2 less than -1, it is less than -1 but greater than -2. If you simplify this, it will be 0 plus 1 -1 and +2 will become +1. So you can take it like this. So for t between 0 and 1, what is the value of y of t? So let's find out. Y of t is equal to integral of, so the overlapping region is from t minus 2 to 1, x1 of tau, x2 of t minus tau d tau. So again the values of these two are 1 and 1 in this particular duration. So observe this value, at t minus 2 it is 1, and at from t minus 2 to 1 both are having the same values. Now if you integrate this, y of t is equal to tau with limit t minus 2 and 1. Now if you apply the limit and simplify this, you should get minus t plus 3 here, or you can write it like 3 minus t, whichever suits better. So minus t plus 3 is the answer. Now let's move on to the next case, that is case 3. Now here I will shift this further to the next division. Minus 2, minus 1, 0 and 1. So this is my x1 of tau. So before plotting that, I will show you. Now in this one I have kept it between minus 2 and minus 1. In the next case I will place it here, that is between minus 1 and 0. So this point, minus 1 and 0. So with this one is also having amplitude 1, and x1 of tau is also having amplitude 1. Okay. Now if you observe, this is my t minus 2. So if you observe, the overlapping region again is between from minus t minus 2 to 1, same as in the previous case, t minus 2 to 1. Here also it is t minus 2 to 1. So how do you define the case here? For t minus 2 less than 0 greater than minus 1. If you simplify this, the limit is between 1 and 2. So for this region, what happens to y of t? So y of t is equal to integral of minus t minus 2 to 1 x1 of tau x2 of t minus tau d tau. Then substitute the values, and I am not going to go through the steps completely since it is having the same values. You will get minus t plus 3 or 3 minus t. So this is y of t for this case. Same thing as we repeated. So I am not going through the complete step of simplification. I directly written the answer for this. Okay. So next go for another case. Case 4. So x1 of tau minus 2, minus 1, 0 and 1 here. In this case, I will move x2 of t minus tau further. That means I will keep this in between 0 and 1 here in this place in the next case. Now I am moving this, I am shifting x2 of t minus tau here. Amplitude is 1, and this is my x2 of t minus tau. Okay. So this point is t minus 2. And this is the overlapping region. Again the overlapping region is same, that is from t minus 2 to 1. So again you will get the same answer for y of t, but let's define the condition first. For t minus 2 less than 1 greater than 0, if you simplify this, it will be from 2 to 3. Now in this particular duration, what is the value of y of t? So y of t varies from t minus 1 to 1 because that is the overlapping region. So we have to take the product of these two, x1 of tau and x2 of t minus tau. Since the limit is same, you will get the same answer as the previous one. Let us Okay, so that's the final answer for this case. Now in the next case, I will move this t minus 2 here. Okay, and let's see what happens. Okay, so going to the next case. So we take it as case 5. Now as I mentioned in the previous case, t minus 2 was between 0 and 1 here, and this case I will moving here, that is a greater than 1, or we can write 2 here just for reference. Amplitude is 1, x2 of t minus tau. Now observe there is no overlapping. So if there is no overlapping, you won't get any value for y of t. So that means y of t will become 0. Now how do you define this case for, since I have kept t minus 2 here, for t minus 2 I will just keep it simple, greater than 1. Okay, for t minus 2 greater than 1, or if you simplify this, t greater than 3. So y of t, so there is no overlapping here. So no overlapping. Therefore, if there is no overlapping, then x1 of tau into x2 of t minus tau will become 0. If these two will become 0, then therefore y of t is also equal to 0. So no overlapping after the values of t greater than 3 for y of t. So that means the signal will become 0. Okay. Now if you summarize this, let's summarize the value of y of t. So first we take the conditions. If you go through, in the first case, for t less than 0, what is y of t? Y of t is 3. So let's write down here, y of t is equal to 3 for t less than 0. Next, second case, for t between 0 and 1, what is the value? It is minus t plus 3 or 3 minus t. And I think we got the same answer repeatedly for case 3 also, that is between 1 and 2. Again it is 3 minus t, and for 2 to 3 also it is 3 minus t. So that means from 0 to 3 here, from 0 to 3 we have the same value for y of t, that is 3 minus t. So y of t is equal to 3 minus t for value of t greater than or equal to 0 but less than or equal to 3. So for this particular duration, y of t is 3 minus t. So coming to the last case, that is value of t greater than 3, this case no overlapping occurs, so y of t will become 0. So y of t is 0 for value of t which are greater than 3. So this is the final answer. Now if you want to plot this y of t, you go for plotting y of t. So apply some values here, minus 1, minus 2, minus 3, minus 4, etc. And here 1, 2, 3, 4, 5. Okay. Now it says for t less than 0, y of t will be 3. So that means for value of t which are less than 0, that is this particular region, y of t will be 3 only. So let's plot that. So this is 3 amplitude for value of t less than 0. Now I have come to the origin itself. Why I will tell you later. Next here, observe this. For value of t between 0 and 3, it is 3 minus t. Now to get the exact amplitude here, so what is y of t? Y of t is equal to 3 minus t. So first put these values. For t is equal to 0, that is y of 0 is equal to 3 minus 0, we will get 3. For t is equal to 1, that is y of 1, 3 minus 1, that is 2. And for t is equal to 2, y of 2 is equal to 3 minus 2, that is 1. And for t is equal to 3, y of 3 is equal to 3 minus 3, that becomes 0. So this particular duration 3 minus t from value varying from 0 to 3, I have calculated the values for this. T is equal to 0, t is equal to 1, 2, 3. For all this I have given the values, and this is what I found. At y of 0 is 3, y of 1 is 2, y of 2 is 1, and y of 3 is 0. So these are the respective amplitude values. Now if you mark this, so at 1, y of 1, y of 0 is 3, we have already at amplitude 3 here, and at y of 1 it is 2, let's call this as 2, and at y of 2 it is 1, let's call this as 1, and at y of 3 it is 0. Now if you join these lines, you will get the signal here. Now this point is 2, this point is 1, and this point is 0. And the last thing says, for t greater than 3, y of t is equal to 0. So from here onwards, the signal will be 0. So this is the plot depending on the values of y of t. I hope you have understood this problem. Okay, and these are the steps that required. If you have any queries, do reply me, or you can put the comment in the video. Thank you for your time.